Okay, this is the factoring fun lesson, and basically, okay, so if I'm the teacher, basically, I would put the kids into groups. Say we had 20 kids, I'd probably do probably 7 groups, 6 with 3, 1 with 2. And so say this is my board, I guess. Ignore the action figures, sorry. Say this is my board, I would write down a number with a bunch of factors. So let's do 96. So I'd write down 96, and then I'd say, hey, class, within your groups, find as many pairs of numbers that can multiply to get you 96. And whenever anyone's done, or whenever 2 minutes is up, let me know who has the most. And basically, this will lead them to find factors without realizing they're actually finding factors. So yeah, they just sit and work. During that 2 minutes, I can walk around and kind of judge what they're thinking and kind of get on their page and understand where they're feeling and what I need to hit and what I need to spend more time on in my explain. For the explore, basically I would hand out this factoring puzzle I found online. The links on the 5E. I don't know what the website name is, but basically, this puzzle is basically at the top of what it's supposed to make into. It has the number, so say it's 24. And then there's 4 little pieces, or I guess for 24 it'd be what? 6 little pieces that can fit into it. So there's 6 notches out of the piece that says 24, and then there'd be an 8 and a 3, a 2 and a 12, and a 4 and a 6. And basically, the page has all these numbers with a bunch of different factors, and so you cut them out. So I would have pre-cut them out, obviously, and then I just hand them to the groups of kids and see if they can figure out which numbers, which factors go with which numbers. And basically that would kind of, because they get the term factoring, and then I don't think I would throw the term prime and composite. I think we could fit that into the explain better. But because basically I can fit those words in, they kind of get the vocabulary and they get the vibe of what they're learning, and they connect that to what they just did in the explore. And so that's that connection, and that gets them ready for the explain. One thing I think I specifically want them to catch on to with this factoring puzzle and the engage before it, is they kind of pick up the powers of 2, especially the higher ones like 64, 96, 32, and they kind of see that they can be broken down into much similar pieces. And so I'm hoping a lot of them recognize that pattern, because that makes factoring a lot quicker for those powers of 2. And even if they don't pick up on that, I hope they can pick up on every even number has a 2 that can be factored out of it, and that makes it easier. So I'm hoping they pick up on those. That would be I guess, my goals for the explore. So, okay, so for the explain, basically the students would just kind of sit there and listen to the teacher speak. I guess the teacher being me in this example. And so to start out my lesson, I would just kind of connect the engage and the explore, and be so class, all day, during this lesson you've been finding numbers that can multiply to make another number. A term for these numbers, these multiples, are factors. Basically, so any number that can be comprised of 2 numbers multiplied together, 2 or more, has those as factors. So basically, for 4, 2 and 2 are a factor of 4. For 6, 3 and 2 are factors for 6, because 3 and 2 can be multiplied together to get 6. So think back on the beginning of this lesson when I gave you the number 64, and you were in groups trying to find the numbers that multiplied to get you 64. Say you found 4 and 16. 4 and 16. Those 2 would be factors, as well as 32 and 2. Those are all factors because they can be multiplied by each other to get you 64. And so basically, all in all, what a factor is it's a number that is divisible. A number has factors if it is divisible by those factors evenly. So like 64 can be divided by 32 evenly, so that makes 32 a factor. 64 can be divided by 2. It can be divided by 4, 16, 8, all of those evenly, which makes all those numbers factors of 64. And basically, okay, so basically teaching you about these factors, we are getting closer and closer to getting you towards prime numbers and composite numbers. Basically, a composite number is any number with factors other than itself and 1. So think the number 8, you can multiply 4 and 2 and 8 and 1. So it's composite because it has more factors than just the 8 and the 1. So on the other hand, for a prime number, which is any number whose only factors are itself and 1, is an example is 5. 5 you cannot get by multiplying any two whole numbers. You have to multiply 5 times 1 to get 5. Same thing with 7. You can only multiply 7 times 1 to get 7. So because you can only multiply any number by itself to get that number, that makes it prime. So examples of composite numbers other than 8, 10. You've got 2 and 5 and 10 and 1. 20, you can do 4 and 5, 2, 10, and 20 and 1. Another example is 30. You can do 6 and 5, 10 and 3, 30 and 1. Lots of different factors there, so all those numbers are composite. So that would be basically the synopsis of what I'd give the students. It would probably be like, I don't know, I would probably go slower and give more examples just because I'd be talking to like 4th graders. But that would be like the general like vibe. Sorry, very quickly, one thing I forgot about the explain, I would also tie in the factoring like branch, I guess like a branch diagram you can do. So really quickly, let me I guess get back into character as the teacher. Basically, so once you find factors of a certain number, you can put it into a what you can call a factoring like tree diagram. Basically, so how it's set up, I'll have a picture here. In real life, if I were a teacher, I would be drawing it on the board, but basically at the top you have the number that you were trying to find all the factors for. So let's do 24. Okay, so two factors could be 12 and 2. So we have 12 and 2 on the next level below it. We also have 8 and 3, and then we also have 6 and 4, and 24 and 1. So those, we have all 8 of those numbers on the level below it. So first we have 12 and 2. That 2 is a prime number, so it cannot have any more factors that are itself. Tell you what, I would not include the 24 and the 1 on that diagram, I don't think. So never mind on that. But basically I would say that 2 is a prime number. You cannot break it down anymore. However, that 12 can be broken down into 3 and 4. That 3 is a prime number, so it would stay on this level, not be broken down anymore. This 4 would be broken down into 2 and a 2, which are both prime numbers, obviously, because they're the same number. And so those would not be broken down anymore. For next, what did I say, 8 and 3? This 3 is a prime number, like it is right here, so this will not be broken down anymore. This 8, however, can be broken down into a 4 and a 2. The 2 is prime, the 4 is composite, so the 4 can be broken down into a 2 and a 2, which are both prime. Then next was, I think, 6 and 4. 6 and 4 are both composite numbers, so the 6 can be broken down into 3 and 2, which are both prime numbers, so we'd stop there. And the 4 can be broken down into 2 and 2, which are both prime numbers, so we'd stop there. Basically, the point of this diagram is it shows you factors that can be multiplied with 3 numbers to get the top number. So like we have the 12 and the 2 and the 24 up here. Well, this 12 and 2 can also be 4 times 3 times 2 equals 24, because 4 times 3 equals 12, times 2 is 24. We could go even further down this diagram and see that 4 can be represented by 2 times 2. So we can do 2 times 2 times 3 times 2 is equal to 24, because 2 times 3 is 6, times 2 is 12, times 2 is 24. Basically, so what this diagram lets you do is it lets you break down these numbers up top into however many prime numbers you want, prime or composite, you can multiply together to get this top number. So I would add that to the explain. Sorry, I forgot it. For the elaborate, I would just hand out the worksheet that I found. I found it on the internet, like I said. With the same with the puzzle, the link is on the 5E. So obviously I don't know what website it's from, but basically I would just pass out the worksheet. I would just walk around. The worksheet basically just has the diagrams I was talking about in the explain, and just with some blanks, and so they'd fill them in and they'd just kind of get the feel for it, get the vibe. And basically I would walk around in the class as they were taking them, or as they were filling them out. And I'd be seeing if anyone was struggling, seeing if anyone was maybe like asking for help from their friend just because they didn't understand it. And I would try to fill in those gaps where students were not understanding it. Honestly, I think they'd be pretty fine. It's just multiplication, and they're fourth graders. I think they could handle that. But I would walk around and just kind of feel, I don't know, kind of not necessarily the evaluate just yet, but I would kind of get a feel for the classroom and see where they were all sitting and where they're all standing. Basically for the evaluate, I would just give the students an exit ticket. I would say, hey, find a number that has at least 4 factors that we have not covered in class and make a diagram for that number. So basically I would pick these up as the teacher on their way out of class, and that would kind of give me a judge of if they understand how to format the diagrams, if they know what a factor is, if they know when to stop the diagram. So that would be prime or composite numbers. It tests everything that I kind of went over in the lesson while still making it really easy to check. And it's I don't know, I think it'd just be like a good test because it covers everything in something that's not too hard to do for an exit ticket. Basically, I think it depends on what they got wrong. I think if they misunderstood how to set up the diagram, I think that's a pretty easy problem to solve. I think if they just did more problems with those diagrams, they would understand how they work. If they had a problem with like multiplication, that's probably just a simple error. I mean, I'm sure they know how to multiply. Actually, I don't know. I think you learn to multiply in like 2nd, 3rd grade probably. Never mind, they probably know it. Anyways, if they don't know when to stop, like on the diagram, say they do 2 and then they do 2 times 1, or 0.5 times 4, like they don't stop at whole numbers, I'd probably need to go over the prime and composite parts again and just kind of figure out like if it's that or if it's the diagram itself that's confusing the class as a whole. But I think that's it for my lesson, so this one was fun. Thank you.